we are doing the chapter based on haloalkanes and haloarenes, and the next topic is nomenclature of aliphatic halogen compounds. As you can see, I haven't written the heading as nomenclature of haloalkanes because I told you in the previous lecture that haloalkanes is a term specifically used for only monohalogen derivatives. So nomenclature mein you have to be very careful. You cannot give general names. You have to see that whether the compound is a monohalogen derivative or it's a dihalogen derivative or it's a trihalogen derivative. Then we have to pay attention to the position. If it's a dihalogen derivative, what is the position of those two halogen atoms? Are they on the same carbon atom? The name will be different. Are they on the adjacent carbon atoms, or are they on the terminal carbon atoms? So it is something you will have to pay attention to. Nomenclature of aliphatic halogen compounds, right? The first section we do is that we take up monohalogen derivatives. This will be the easiest one because you have already done a lot about it. Classification में हमने इतनी बातें की है in monohalogen derivatives की. So the nomenclature is very simple. In IUPAC system, these monohalogen derivatives are named as haloalkanes, right? And the word haloalkanes is written as one word. There is no space between halo and alkanes. And in the trivial system, or which we also call the common system, they are named as alkyl halides, right? And these are two words. Alkyl is one word and halide is another word, right? I don't think it is very difficult to understand or remember. We'll just do a few simple examples in this case. If we have a compound like CH3, CHI, CH3, what would be the name? Very simple. We start numbering. We can start the numbering from whichever way. 1, 2, 3, 1, 2, 3. The name would be, you just have to give the locant. Haloalkane mein you just have to add the position of the halo atom. The name is 2-iodopropane, right? 2-iodopropane. And in the common system, what is the name? It is isopropyl. When you write down alkyl, you have to see whether it is N-alkyl, it is isoalkyl, or it is tertiary alkyl. You have to pay attention to that. As you can see, this one is a isopropyl iodide, right? The examples in this case, in the first class, which is the monohalogen derivatives of aliphatic halogen compounds, examples in this case are very simple. If there are other functional groups present, then you know the priority. In the presence of other functional groups, halogen atom becomes a substituent. In any case, its name is written as a substituent. Its name is never written as a suffix. It's always written as a prefix, the way name of the substituents is written, right? What we have to pay our attention, more attention rather, to is the second section. The second section of the compounds here will be the dihalogen derivatives. When you derive the halogen compound, aliphatic halogen compound, from an aliphatic hydrocarbon by replacing two hydrogen atoms by two halogen atoms, the resulting class of compounds is known as the dihalogen derivatives, right? Now these dihalogen derivatives, they are of following three types, right? This is very important because nomenclature में अगर कभी question पूछा जाएगा, इसी से पूछा जाएगा, because there are a few things to remember, right? Following three types. What are those following three types? Number one is the first class of dihalogen derivatives is known as alkylidene dihalides, right? And ये जो alkylidene dihalides name है, it is their name in common system. आपने nomenclature में ये देखा होगा कि ज़्यादातर नाम याद रखा जाता है IUPAC में. It is not important if you do not know the name in the common system. But in this class of halogen compounds, dihalogen derivatives, you will have to pay all the attention to the names in the common system. Alkylidene dihalides. Which dihalogen derivatives are alkylidene dihalides? Those in which the two, because they are dihalogen derivatives, the two X atoms, chloro, fluoro, bromo or iodo, are present on the same carbon atom. They are present on the same carbon atom. In that case, the compound, the dihalide, is a alkylidene dihalide. Right? Remember it, same. Now, ये जो same position होती है, it is called as the germinal position. When the substituents are present on the same carbon atom, it is called as the germinal position. Therefore, these dihalides, which dihalides? Alkylidene dihalides, are also called as gem dihalides. You must have heard about the class, gem dihalides. Now, what is a gem dihalide? A dihalide when both the halogen atoms are present on the same carbon atom, right? If we do the examples, if we write down the examples are like this. We have CH3, CHBr2. Two hydrogen atoms have been replaced, but they have been replaced from the same carbon atom. Therefore, both the halogen atoms are on the same carbon atom. In IUPAC, we will simply call it 1,1 dibromoethane. Right? It is a dibromoethane and 1,1 एक ही pair. But what is the name in the common system? The name is ethylidene dibromide. And as I said, in this class of compounds, the names in common system are important. You should be able to write down these names. And it is not necessary that these halogen atoms will be terminal. They can be there in the middle of the chain also, like CH3, CCl2, CH3, right? What was the compound? The compound was CH2, right? Propane. Now, both the hydrogen atoms have been replaced by two chlorine atoms, and those two chlorine atoms are present on the same carbon atom. Since they are present on the same carbon atom, it is an alkylidene dihalide. In common system, what will be its name? Its name will be propylidene dichloride. My board is very small. I'm really sorry for that. And in IUPAC system, इसका नाम क्या होगा? IUPAC is very simple. This is 1, this is 2, this is 3. 2,2 dichloropropane, right? But you will have to pay attention to this. These are alkylidene dihalides if your two halogen atoms are present on the same carbon atom. We'll continue in the next presentation.